All right, let's dive into something that sounds like it's straight out of a sci-fi movie, but is actually becoming real as we speak: quantum computing. This is a field that basically throws out the old rulebook for how computers work. It taps into the super weird, mind-bending principles of quantum mechanics to unleash a kind of power we've never seen before. Let's see how it all comes together.
So what's all the hype about? I mean, really, what's the big deal? Well, it all boils down to one word: speed. But we're not talking about just a slightly faster version of the supercomputers we have now. Oh no, this is a totally different way of thinking. It's about processing information in parallel, on a scale that is just massive.
To really wrap our heads around this, let's try an analogy. Okay, imagine you're playing a game of chess, and you want to figure out every single possible move your opponent could make from this point on. How would a computer even begin to tackle a task that enormous?
Well, the laptop or the phone you're using right now would have to go through it the slow way. It would check every potential move one by one by one. It's a long step-by-step process. But a quantum computer, it does something incredible. It simulates all of those possibilities at the exact same time. It sees every path at once and finds the answer in a blink.
Right, so how in the world is that even possible? How could a machine just calculate everything at once? The secret is in its fundamental building block. It's a huge leap past the simple on or off switches that run our computers today. Let's talk about the magic of the qubit.
And this is where things get a little weird, but really cool. Classical computers use bits, right? Super simple. They're always either a 0 or a 1. Think of a light switch. It's either on or it's off. That's it. But quantum computers use qubits. And a qubit can be a 0, a 1, or, get this, both at the exact same time.
Yeah, that mind-bending property has a name. It's called superposition. This is a key idea from quantum mechanics that allows a single qubit to hold way more information than a regular bit. It's not just on or off, it's living in this state of all possibilities at once.
To make this a little clearer, just picture a spinning coin. While it's in the air, before it lands, is it heads or is it tails? I mean, you can't really say, right? You could argue it's kind of in a state of being both. That spinning coin is a perfect way to visualize what a qubit is doing in superposition. It's holding the potential for every outcome, all at once.
But superposition is really just a beginning. The power truly explodes when you link these qubits together through this other bizarre phenomenon, something so strange that even Albert Einstein called it spooky action at a distance. This is where we get the entanglement advantage.
This spooky thing is called quantum entanglement. It's what happens when two or more qubits become fundamentally connected. Their fates are completely intertwined. So whatever happens to one of them instantly, and I mean instantly, affects the other one, even if they're on opposite sides of the galaxy.
So here's a simple way to think about it. Imagine you link two qubits. The moment you measure the state of one of them, let's say it locks in as a 1, you instantly know the state of its entangled partner. By linking tons of qubits this way, you create this incredibly complex, interconnected system where a single action can affect the whole set. That's how you solve problems with a complexity that grows exponentially with every single qubit you add.
Now, I know this all might sound like very abstract, out there theory, but the thing is, it's happening. Right now, scientists and engineers are actually building these incredible machines, and let me tell you, they look nothing like you'd expect. Let's look at how this is moving from theory to reality.
Seriously, forget your laptop or your desktop computer. A quantum computer looks more like a piece of futuristic art. It's often this stunning chandelier-like machine, just dripping with a tangled maze of gold, silver, and blue wires and tubes, all designed to keep those delicate qubits in their fragile quantum state.
And the race to perfect this tech, it is absolutely on. A huge pivotal moment came back in October 2019. That's when Google announced its Sycamore processor had achieved quantum supremacy. What that means is it performed a specific calculation in just a few minutes that would take the world's most powerful classical supercomputer thousands of years to complete. That moment proved this was really possible, and it kicked the global race between giants like IBM and Microsoft into high gear.
So, okay, a super fast sci-fi computer is cool and all, but what does it actually mean for us? Why does any of this matter? Well, the potential applications are poised to completely revolutionize our world in ways we're only just starting to wrap our heads around.
I mean, the potential breakthroughs here are just staggering. Imagine discovering new medicines and drugs by simulating molecules in ways we never could before, or creating truly unbreakable data encryption. This technology could supercharge AI and machine learning, help us design way better batteries for things like electric cars, or give us weather forecasts with pinpoint accuracy.
The impact is going to be felt in pretty much every industry you can think of.
And hey, on a lighter note, once this technology gets really powerful, the possibilities are almost funny to think about. Who knows, maybe one day a quantum computer really could solve some of life's little mysteries, like, where on Earth that other sock actually went.
And this really gets us to the ultimate takeaway. We are standing on the brink of a new computational revolution, one that's going to give us the tools to solve problems that are currently impossible for even our most powerful supercomputers. So that leaves us with one final thought to ponder. If you had that kind of power at your fingertips, what impossible problem would you solve first?